So our next lesson will be rationalizing radical expressions. Now, rationalizing is simply the process of getting rid of any square roots in our denominators. We are not allowed to have irrational numbers, aka square roots, underneath our fractions in our denominators. So rationalizing radical expressions. Well, for example 1 here, we have the square root of 3 over 7. This is the same thing as saying the square root of 3 over the square root of 7. So when we have this, the square root of 7 here is the problem. We can't have that. So we need to multiply the top and bottom by the square root of 7. So on the bottom here, the square root of 7 times the square root of 7, well, that's the same thing as the square root of 7 times 7, which is the square root of 49, and that simply becomes 7. So our denominator is 7. Our numerator, the square root of 3 times the square root of 7, is the square root of 3 times 7. So your final answer is the square root of 21 all over 7. Now, one thing to note is in your numerator here, the square root of 21, we need to double check to make sure that that is as simplified as possible. So for this problem, it might be a bit redundant, but in other future problems that you might see, it is very important to double check it. So the square root of 21, well, that only breaks down into 3 and 7. Both of those are prime, and they do not share any, there are no pair of numbers in here, so there's nothing we can move out in front of our square root there. So the square root of 21 over 7 is your final answer. So let's take a look now at another example. So example 2 here. We have 16 times the square root of 12 all over 15 times the square root of 2. Excuse me, that is just supposed to be 6 times the square root of 12 all over 15 times the square root of 2. So this, we can first simplify that 6 over 15. Well, 6 over 15. The greatest common factor between 6 and 15 is 3. So we divide the numerator and the denominator here by 3, and you get 2 over 5. So our fraction is now going to be 2 fifths, and then the square root of 12 over the square root of 2. Well, what can we do with that? The square root of 12 all over the square root of 2. That is the same thing as saying the square root of 12 divided by 2. Well, 12 divided by 2, that's just the square root of 6. And the square root of 6, that is going up top in our numerator there, because 12 is bigger than 2. So your final answer is going to be 2 times the square root of 6 all over 5. So now, last but not least, example 3. Example 3, we have 5 over 2 times the square root of 3. So that, well, we need to get rid of that square root of 3 in our denominator. So all we do is you multiply the top and bottom, numerator and denominator, by the square root of 3. So our numerator is just going to be 5 times the square root of 3. Our denominator is going to be 2 times 3. We get this 3 here by multiplying together square root of 3 times the square root of 3. Again, square root of 9. Square root of 9 is a perfect square because it is the same thing as 3 to the second power. And then you just get 3. So we multiply 3 times 2 there. So our final answer is 5 times the square root of 3 all over 6.